reject new contract starting with 0xEF byte is expected on the mainnet with the London upgrade, which is about a month away. It can be considered as a prep for EIP-3540 object format, which can be expected in the following network upgrade. To talk about the DO proposals, we are joined by the co-authors, Alex, Paweł, and Andrei. So welcome everyone. Before we dive into the proposal, may we have a quick introduction of the co-authors? Anyone can go first.
Okay, so maybe I'll start. My name is Paweł, and I'm working on the core Ethereum platform for many years. I started before Ethereum had launched. Since then, I mostly work on the EVM and propose new changes, review changes proposed by others, and yeah, that's what I have been doing for long years. Yeah, I think that's enough for me.
Well, Andrei, you want to go?
Sure. Hi, I'm Andrei. I work with Paweł and Alex on various C++ projects for Ethereum Foundation and EVM related stuff.
Yeah, I also likewise to Paweł. I've been around in Ethereum for quite a bit. Initially contributed to Ethereum.js and then Solidity, and to date I'm still contributing to Solidity mostly on language design, but next to it I also have been involved with the EIP process for quite a bit, and work with Andrei and Paweł on the EWASM/Epsilon team, and mostly we have been concerned with reviewing EVM improvements or proposing our own improvements, and the object format is just one of these.
Thank you for introduction. So without further delay, let's dive in.
Okay. So thanks for introduction. Yeah, let's start with screen sharing. Okay, so what we like to present today is EVM object format. This term is related to two EIPs that were mentioned in the introduction. The main one, which is what we're going to spend most of time on, is EIP-3540, which specifies this first version of EVM object format. And we also have EIP-3541, which is kind of a needed step into deploying the EOF to the mainnet. And we'll touch it a bit during the presentation. But what we want to start with is to give some introduction and motivation why we propose this. I will show how familiar is to that. Maybe it's like known fact for core developers, but I'm not sure how much is it known for contract developers and app developers. But current EVM design, EVM can execute like whatever byte array of the code it gets. So it can be some nonsense set of instructions, and it doesn't really matter. The worst thing can happen is that EVM will return some failure, and this is still like in something that will happen on the blockchain. EVM object format is kind of proposed to add some additional structure and also introduce some set of restrictions to the EVM code, so we can get some benefits out of that. And what is the main motivation? Like, why this is good thing? I think the critical aspect of current EVM design is that it has some some positions in the code that are marked as a valid jump destinations. And this is like this, it has some artificial special opcode that marks these places, and there are also some additional restrictions related to that. And the problem is that you need to know which are the valid jump destinations before you can actually start executing. There might be like a bit clever way of doing that, but in the worst case, you have to analyze all of the code you got. And this is some attack vector, but it's also some like performance penalty to do that. These results can be cached for most cases, but it's difficult to cache it for init code, which is used to create new contracts. And there are also some attacks related to that. And yeah, this is something, but it's not super great. And so one of the things that the structure may get us, the structure of EOF, is that we can get rid of the need of doing this. Secondly, and this is something the EOF version 1 will get, and we'll get to that very soon, is that there are some parts of the bytecode that actually doesn't mean to be there are bytes that store some data, and EVM can read this data, but the control flow never reaches these places. But still, we need to analyze these parts of the code, even though they're not going to be ever executed. And as I said, current EVM implementation can live with that. It's not great, but it starts hurting some other things. One of them is on-chain code analysis, or some, let's say, L2 scaling solutions. And one of them is optimism and optimistic virtual machine, as it was called previously. And it will do the code analysis on chain, and it would be nice if they can skip the data part of the code. And this is also related to some other proposals where there were some other marks in the bytecode that's a separated code from the data. But EOF version 1 will provide this feature. And there are some other benefits that can be that we can by utilizing EOF we can benefit from. And we'll get to that later, but some of these are functions and subroutines inside EVM, something that has been discussed 1 or 2 years ago, which is code versioning. This is some way of having backward compatible changes to EVM. And this wasn't done because there was some concerns about how this should be deployed to the network, and also something that was also considered, but it's difficult to roll out in the current EVM, which are multi-byte opcodes. Okay, in the next section, I will go a bit more detail into how exactly this EOF works and how it's specified. But if there are any questions, or some of my colleagues would like to add anything up to this point.
I've got one question. So the EOF isn't the EIP, but it's related to this. Like, so the EOF is what you're defining, and the motivation is about like making this work. And then the EIP is something that makes that possible, but it's not making all these things possible.
Yes. So EIP, yeah, that will I will talk about that. But the EIP introduces EOF as a concept, as a kind of container, and also introduces the first version of that. And the first version, it has only, as a feature set, has only code and data separation. This is, I think, so we limited the number of features because, as you may know, it's difficult to roll out like big feature set as one like change. And code and data separation, it's quite easy to do this way, and I think it's quite important feature to have rather soon than later.
So this is like, so what you're presenting is sort of the long-term vision of where you want to get, and the EIP is about like an incremental step to get there, but it's not going to give everything.
Yeah, I'd say that. So I wouldn't like personally commit like to all of the features. I'm not sure how they are important, how much they are important, but I think it opens a path to deploy these in more like without really discovering new ways of doing it. So you can use the container, and maybe you would need to bump the version, but there's like path forward to enable some of these. Depending of, it mostly depends on the how much this is worth it and how much this is needed to be on the mainnet.
I guess to give maybe a bit of context how this started is one part is the subroutines proposal, right, which has been discussed at quite a bit of length over the past year. And during last year, one of the bigger discussion points was how restricted or unrestricted subroutines should be. And actually that entire discussion really centered around the effect on the JUMPDEST analysis. So basically the subroutines proposal, the Achilles heel of that was the JUMPDEST analysis impact. So that was one of the reasons we started to look into this. And the second reason was I guess the multiplied opcodes, because that came up as a, I mean, it's a recurring thing. It came up last with the EIP-3540. Meanwhile, a workaround has been identified. But if we would have, a system like EOF, you wouldn't even need the workaround. And the last trigger was really the code and data separation, because I mean, there was this other EIP to just propose the code and data separation, and it has been out as an idea. That particular way of doing it has been out as an idea for, I guess, over 2 years, and it has been recurring. But now it seemed like that it may be considered, and some people, some core developers were not entirely happy the way that the EIP would do the separation. And practically organically, this discussion led to, into a proposal similar to the EOF. And maybe one more explainer on this code and data separation, the optimism case itself. So the way optimism works is they, of course, have a sidechain, but you need to be able to provide a fraud proof on mainnet. And as part of that fraud proof, you need to be able to execute EVM bytecode, which is deployed on Optimism, and you need to able to execute that unchanged on mainnet. And the way this is made possible is that for every external call in that code, the Optimism Solidity compiler inserts some kind of guarding code. And what they need to ensure during deployment on chain is that guarding code is present, and there's no code which I guess, which is not unreachable and has no guarding code. I mean, that is the main concern they have, is that they need to be able to analyze every single part of the bytecode and need to know that every single external interaction by the contract is guarded. So that's what this code data separation is really important.
So there isn't like a hidden There isn't like a optimism's trying to run and then there's like something hidden somewhere that they're like, oh wait, we can't actually run that.
Yeah, the hidden part is, so the problem with the analysis, I mean, it's just really hard to analyze when you really don't have any kind of separation, because code may or may not be valid. And you also have like a limited gas you can spend on this analysis on mainnet. So in the general case, this is just practically impossible to validate, all EVM bytecode. They need to have a subset already. So they set limitations in the compiler, and they wouldn't need those limitations with the separation.
That context helps a lot.
Okay, yeah, thanks for help, Alex. So now I will try to like give overview how this EOF works, and the core part is EOF Prefix, which is some set of bytecodes at the beginning of the deployed account code, and this is a way to like to differentiate the legacy code that doesn't have any structure, doesn't have this prefix, and from the new prefixed bytecodes. And so by itself, it provides code versioning because the prefix has the version. And the way the EOF bytecode or EOF code is deployed is designed the way that it is guaranteed to be valid when it's deployed. So I will get to the point how exactly done, but the prefix is just some number of bytes. So it starts with some specific 1 byte value, which is EF hex value. This is not used by any instruction currently. We also identify that so far, at least when we checked, none of the mainnet contracts start with this bytecode, so that's like a good thing. And then after this will follow some additional magic bytes, and so we don't know how much we'll need of these, and but there's a chance we'll not need any of these, but we'll see how it goes, and I'll explain in a moment why this is unknown at this point. And finally, there will be a 1 byte with the EOF version, and what the EIP proposes is specification for EOF version 1. So the value 1 will go there. Critical part of this EOF design is that there will be a validation step before the code can be deployed. So that's why it will be when you encounter a code that starts with the EOF prefix, you can assume it's already valid according to the version it promises in the prefix.
Can you say a little bit of what it means to be valid, like why that's kind of important?
So the prefix will be how I said it will be. That's one thing, and then there will be some additional rules and restrictions which depends on the version. And I will show what rules do we propose for the EOF version 1, and these rules are checked on deploy time. So yeah, we'll get to that in a moment. So the validation is done when someone wants to create new contract and deploy new code. So far in the EVM, this is done by executing init code. It's like some ephemeral code that is supposed to actually generate the end result code, which is going to be deployed in the Ethereum state. And we'll add additional steps in this process. So we'll do the validation steps both for init code. So first, we require the init code to be also the valid EOF code, and this is if it's valid, it will be executed, and if execution succeeds and produce the code to be deployed, this end result code will also be validated according to the EOF rules. So before we go to the specific rules for EOF version 1, there's one gap I want to explain. So this is like the origin of these magic bytes that are not specified yet, and the reason why there is additional EIP proposed for to be deployed very soon. We want to make sure that there doesn't exist any bytecode that has some kind of valid EOF prefix right now. So that's why the whole EOF deployment will be done in 2 hard forks, so like 2 EIPs. And in the first hard fork,
could I interrupt?
Yeah, go ahead.
Maybe just to, I feel like maybe this would answer James's question. So, if you go back one slide, so what if invalid bytecode is deployed before this is activated? We want to have this really strong promise that if you look at the blockchain, and if you look at code, and the code starts with this EOF prefix, we want to have very strong guarantee that if you see such code, that is actually valid code, valid EOF code. And if you would be able to deploy code, prior all these like different hard forks, which has like an EOF prefix, that would mean that in the future you would have two kinds of like EOF looking bytecode, and you would not be able to tell which is valid and which is not. So we want to make sure that once you can deploy this EOF bytecode, it's always going to be valid bytecode. That is the whole reason we have to do these different steps. I'm not sure, James, does that help in the explainer?
Yeah, so there's like the things that are possible to deploy on Ethereum are really huge. And then you're saying that if it's within this subset of rules, now you have sort of like a smaller thing, like you promise. I guess I was just trying to understand from the general perspective of like why having valid code is important, but I think you're kind of getting to that. Like from someone who hasn't really heard about making sure like a block is valid or things are valid, that term kind of gets thrown around for a lot of different things. But I think you're like getting there, but that helps a lot.
Yeah, okay, so maybe just briefly, I think Paweł maybe mentioned it earlier, but basically today the only thing which means that the bytecode is valid, there are not many things which would say that, but the only requirement is for code validity is that if you do a jump, it goes to a place which has this JUMPDEST marker. That's the only rule which exists today. And this analysis, JUMPDEST analysis, checking that every, basically just building up a list where all of these markers are, that is the JUMPDEST analysis. And that's the only thing EVMs do today. It's not really a strong guarantee. And if you have strong guarantees, then you can change all this logic and make it cheaper and faster and quicker and remove some of this. That's the goal with validity.
That helps.
Okay, so I will try to explain how actually we plan to deploy these. So we'll have two hard forks, but by hard forks I mean EIPs included and some different hard forks happening at different time. And in the first hard fork, oops, not this way. In the first hard fork, the EIP-3541 is going to be deployed. And this is simple change, and it's like the only thing it does, it forbids deploying code starting with this EF byte at the very beginning. This has been improved for London, and it will go in London, and it's going to happen somewhere around summer this year. You may have like better dates than me, but yeah, we are very satisfied we could get it in. After this date, there is no way to deploy new bytecodes starting with EF. However, there might be some bytecode starting with EF already on the at the moment London forks. What we're going to do after the London hard fork is that we'll analyze all the bytecodes that are on the chain, and probably will also inspect all of the testnets that are important to us. And then because the search space for these magic bytes following EF byte has been frozen by the first hard fork, we can like find some additional magic bytes that are not happening anywhere on the mainnet and on the testnets we want to keep running on. So this is the way we'll pick some additional magic bytes, and we'll get some multi-byte like prefix or like indicator that this is EOF code, and we'll know none of these exist in the state at the moment we'll specify it. And finally, in the hard fork 2, which will hopefully introduce EOF version 1, we just need to do it. Yeah, I hope I didn't confuse you a lot by this. If there's any questions so far.
I have possibly a dumb question with it. So
yeah,
if I have like people have addresses that are 0xEF that they have ETH and they use whatever on, this doesn't affect any of those things, right? There's
no,
separate.
It addresses doesn't matter. It's the code that resides under the address. So, yeah, for the user controlled, what is the name? User owned, no, external owned.
Externally.
Yeah. So yeah, it doesn't matter. So it's not about the addresses, it's about the code. So
if you have a 0xEF address, you shouldn't feel special. Like you caught something.
You can feel so, but yeah, for EVM it doesn't matter. Yeah.
Yeah, cool.
Okay, so finally, the EOF version 1. What is the version 1 about? So the main feature is the code and data separation, as we mentioned before, and how it looks inside. Well, it will have the EOF1 will have the EOF prefix with version 1. That's what we already defined and discussed, and there will be two like parts of the codes that will follow. The second part is like section headers that defines what the section will be after these, and the section is the kind of the payload of that. So it creates some kind of container that can be similar to like many other like computer science, like yeah, other specifications. So section headers. So in general, this is kind of, yeah, it's something that goes above the code and data separation, but we want to be like generic enough so these things are likely to change in the future, but they are kind of extendable to new section kinds, and but we can keep the container format as is specified in version 1. So the section headers specify what sections will follow, and they are like 1 byte section kind indicator and also the size of the section, which has 2 bytes allocated to that. This is not like set in stone as for now, but we selected some values that kind of make sense for the more or less sizes of the contracts currently being used. And in the first version, we will have three kinds of sections. The terminator section, which is kind of a special way of marking that there are not any more section headers specified in the container. And yeah, and there are two main, well, 2 sections that can actually have some payload, which one is for the code and one is for data, unsurprisingly. Do you have anything else for that?
I have a quick question. That's okay.
Yeah, sure.
Yeah. So the previous stuff. Thanks for letting me interrupt a bunch, but this is really fascinating. So the previous stuff is all set in stone, pretty much, that you talked about. This stuff is the things that are going to be worked out, but will be worked out before the next hard fork, before the next thing EIP that you implement. This is that a correct understanding?
Yeah, I would assign like 3 different levels to that. So what is for sure that we will forbid this this code. We will forbid deploying code starting with this special byte EF. And this is for London, so I expected it will be on mainnet soon. And the second level, we are committed to this EOF prefix. It's simple enough. So, and we don't find anything. We don't have anything that's simpler than that. And finally, how exactly EOF version 1 will look like? Yeah, it's very much up to discussion. So I think my understanding is like we'll try to intensify working on it after the London is finished, because like people are busy with that as well. It's quite, I think it's quite hard on deadlines, the London hard fork. So, well, we don't want to distract core devs with that yet, but so maybe there will be some like better ideas what exactly the F1 would look like. But we are more or less committed to this version. So why I did like put this like separate prefix and this the first byte rejection, because I've seen some people, including Martin Svende, mentioned that even if this like whole EOF will be different or like reworked, rejecting this first byte is valuable because it enables a lot of options, including this one. I'm sure that's a good answer to the question, but tried my best.
It's great.
Yeah. I would add that I think the confidence level in what is, I mean, explained here with these sections, I think we're pretty confident that there shouldn't be too many changes to this, because this work, I mean, this was quite a few iterations. I would say like, you know, over like five, 6 iterations of different designs. I mean, this is pretty simple stuff, but even this simple stuff you can do in so many different ways. And those different iterations were discussed with some core devs and the Solidity team as well. So it had like a different input. So I kind of feel like that there won't be too many changes to this. If the you know, if this first feature of code and data separation and this is good enough, then I think the design is pretty good and maybe unlikely to significantly change. But yeah, as Paweł said, everybody is really busy with 1559. So it just doesn't seem to be productive to try to interrupt people right now.
Okay, so I think like one sentence summary is that yeah, EOF1 will have some sections, and there will be like code section and data section, and I think it's enough to know that at this point. So I think there are two additional topics related to the specification. I will try to make it short, so not to bore you so much. So there was some question about what this validation means, and these are actually the 6 EOF1 validation rules, provided that this previous container specification is known. And it's not super critical to understand all of these right now, but these are specified in this way, as you can see. So for example, we define that there must be there must be exactly one code section in this container, and then maybe there may be one data section. So you can have 0 or 1 data sections in the container. Yeah, obviously you can like try to tweak it a bit if there's some like good reasons to do that. For example, like to allow only data section if someone wants to that. We didn't find good reasons to allow this. Yeah. So I will not like go very much into details. One more thing I can say about that, we paid quite a lot of attention to that, like why it's this way. It's rather designed to be more restrictive than be super like free to do many weird things. So we prefer to be yeah, rather actually to be as much restrictive as makes sense. It is always easier to lift restrictions later than try to force additional restrictions on something that is already live in the network. And yeah, so this is kind of like summary of the format. So in like full view, like it starts with this special EF format byte, then will be some magic bytes and version byte, which 3 of these build EOF prefix, and then we'll have section headers, which are compound of section kind and section size. And the 0 means the termination section kind, which kind of separates section headers from the section contents. So I think you can come up with much more complicated byte containers, but we tried to keep it simple. There are some other ideas how to design that. This is what we currently have. And lastly, in terms of spec, before we can go to some discussions. So as I mentioned, like this kind of the behavioral changes to the EVM are 2 things. First one is this validation step, which actually happens twice during contract creation. And second part is some changes to the EVM execution. And for that, we tried. So the confusing term is code, what we realized, because code means something that is deployed as a part of the account in the state tree, and here we want to like kind of a bit redefine that. So the code is the content of the code section, and the whole bytes of the what is in the state is we call it here container to make a difference. But there's some changes to the EVM execution, and in my opinion they're quite minimal. So the fundamental change is that JUMPDEST analysis will still has to run before the execution, but it only needs to be done on the code section, and the other parts can be skipped. So other parts are the container definition and data section if they are present. And the second fundamental change is that the execution starts at the beginning of the code section. So the program counter of the EVM doesn't start at 0, it starts when the code section starts. And that's mostly like the two fundamental changes. And the other part kind of like consequences of that. So yeah, considering like we have 15 minutes left, I think it's not so super critical to go into more details about that. There are additional like specific rules specified, but it mostly clarifies that some of the existing instructions doesn't change the behavior, or like clarifies how exactly it's supposed to behave, but mostly it means they are not implementations, they are not changes needed to the EVM implementations.
I think what might be interesting to explain now is what data usually is on, in current like code in current contracts.
Yeah, that was going to be my question. And along with like size, how big is data?
So for us, like data is natural, like all this discussion, because we deal with this on a daily basis. But yeah, it occurred to me that maybe, yeah, just explaining what use cases data has. And the first use case, which is extremely common, right, is when you deploy a contract, you have this like initialization code, the contract runs, and then it returns the actual runtime code, which will stay on chain. So the actual contract code. So every contract deployed has already two parts. It has like this initialization code and has the actual contract code as data. Right? Does that make sense? Before I go any further?
Yes.
And
I think I'm following. But keep going now. Fine.
Yeah. So the runtime, what we call the runtime code, that is what ends up on the chain, right? And this initialization code during contract deployment, that is only run at contract deployment. It doesn't get stored anywhere. And this runtime code is considered data for the initialization code. So what this means, at the time you deploy a contract, you have this very large chunk of data which you need to analyze. But you need to analyze it, but in the current case, but it will not get used for anything. This is analysis. So that's one giant piece which happens all the time. And the second case where data happens is practically every single Solidity bytecode has data, because it has at the very end something called metadata, which is practically a hash and like a version byte of what Solidity compiler was used. And this metadata can be used by contract verification tools like Sourcify or Etherscan to verify when somebody supplies the bytecode verification, so like the sources for the bytecode, this metadata can be used to actually validate that the people submitted the correct sources. So this means that every single bytecode since probably like 2017 has metadata at the end. And there's no real separation, and all of that is by the current EVM is considered like as code, and it's not really nice as a design. And basically things like Optimism has to get rid of the metadata because they cannot really handle it. I hope this clears up for, I guess, what data is. And there are many other use cases, like I guess one other use case is like factory contracts. So if I remember correctly, something like Gnosis Safe has like a factory contract, and a factory contract is basically a contract which will create new contracts. And I think Gnosis Safe works like this, that it has the safe contract, And when you create a new safe, it deploys that safe for you. So there's definitely a lot of cases where data is part of bytecode. And then there are like more other minor cases where it makes sense to store some larger pieces as data. It really depends on the compiler what they decide.
So looking at this list here, does that mean that code is analyzed for jump destination? Like that data, that's code is analyzed at this point, or does that skip at the
Yeah,
point?
it's analyzed every single time you run code. Every single byte is analyzed, whether that is data or code, because the analysis doesn't know what it is, right? It is run every single time.
This allows you to only run it on code. Changes?
Yeah, I mean, this change, yes, it would allow to not run it on data, and any future improvements could make this even better. But the first version, by design, is really minimalistic.
Okay, one more note is that we have implementations in GEF in V1, like proof of concept implementations. So there are links included in this slide just for reference. And finally, we can discuss some potential like future use of EOF. So something what could be done in like EOF 2 or further versions. So we mentioned some of these during the presentation. The list is not like very structured and very ordered. But what Alex almost touched is that in the first version we separate code and data, but still the JUMPDEST analysis has to be done on the code section. So we limit the size of the JUMPDEST analysis, but what could be possible in future changes is that to actually encode something like JUMPDEST table, instead of trying to find these places inside the code, looking for some special marks, we could encode that as in some other section. So the good part of that is like instead of scanning the whole code section, it would be enough to just load this table in some internal representation, and so that makes the code bootstrap much more efficient than the currently we have. Yeah. So so other option which I'm kind of interested in is that this is kind of additional, I think, unwanted property of the current EVM is that there is no clear point where it terminates. So there are multiple conditions when the execution terminates. Obviously, there are some like exceptions that can happen because of the incorrect instruction execution, but there is no like stop point you can identify up front. So your interpreter has to check multiple conditions when it runs, and this is much less efficient than like any kind of proper virtual machine design. We prototyped that, but having like clear stop point can give up to 7% speed in one of the implementations. So this is also can be kind of embedded in the future EOF versions. Yeah, and there is another page of that of possible changes, and I'm happy to give voice to Alex or Andrei if they want to talk about these.
Well, I guess this unordered list has probably 4 items which are kind of like interrelated, if not 5. So basically anything around like this control flow, which means jumps. There's so many different options which have been proposed, and by others or we considered. So one option is something like the subroutines proposal was to have something like subroutines. Another option is to maybe only have like relative jumps or static jumps with relative addressing, and maybe get rid of JUMPDEST or have a get rid of JUMPDEST entirely. I mean, that requires having the static jumps, or if you cannot do that, just have the JUMPDEST table, or introduce actual like EVM functions instead of subroutines. There's so many different possibilities which can be done, and I think this is something we want to explore after EOF 1 goes live. But it's well, it's really early to tell which option is the best. And I mean, each of these options have been have like different kind of motivations. So it's quite a bit of work to actually go through all of those, you know, the different options and the motivations, and judge which one is something which is nice from like a research point of view, you know, that like a purist / research that you want like a nice EVM versus practical, you know, benefits. But I do expect that there will be at least one kind of change or improvement relating to I guess control flow, because it is a recurring topic. So I think this reduces the list quite a bit. And then we had, I guess we had this multi-byte opcodes. I mean, right now it's not possible to, for a long while it was, I guess the view was that it's not easy to introduce multi-byte opcodes. And what multi-byte opcode means is an instruction which is encoded in more than 1 byte. But there, a workaround has been identified. So if somebody really wants it, I think it's possible to do it now. But with EOF, you wouldn't need a workaround. And the workaround, what the workaround means is that you would have an extra byte. So if you want like a 2 byte instruction, you would need to use 3 bytes. But with EOF, you could do it in 2 bytes. And while that single 1 byte doesn't seem like a big thing, the EVM bytecode is, and current mainnet is limited to roughly 25K. So it's quite a restricted, you know, size people have to deal with. So even saving 1 byte, you know, if you need to use that instruction like 100 times, that's quite significant. And then I guess going into another set of like bigger discussions which are relevant today is how to deprecate features. And the self-destruct has been like one of the, I guess, the key examples for deprecating features. And currently it's really hard to deprecate stuff because you have to be conscious of what you break with deprecation. So mostly it is only possible to somehow self-deprecate things where you still keep it somewhat running, as opposed to just outright removing the feature. And that can be observed by all these discussions regarding self-destruct, where there were proposals just to remove it or to change its behavior quite a bit. And what I guess what London ended up with is just reducing the refunds relating to self-destruct. If you would have something like the EOF, you could very easily state that, say, on EOF 2, no contract can have this bytecode, this instruction. Self-destruct is just one example, but we have a bunch of other instructions which are legacy and they're not really used anymore. And I think a lot more of this discussion around deprecation will be becoming a more hotter topic and relevant as we get closer to the Workle tree migration, because there's a lot of want to do these cleanups, and a lot of these cleanups actually coincide with making the tree structure nicer and easier to deal with. Yeah, I guess this account abstraction, I'm not sure how relevant of an example it is currently, because the discussions died down regarding account abstraction quite a bit, and EIP-3540 seems to be an alternative route to it. And in fact, the team who worked on account abstraction is behind 3074. But if at least that kind of account abstraction design would come back into consideration, it would be made quite more simpler with EOF. Because one big issue with account abstraction with the proposal is how to determine, how much bytecode must be run by the miner before it is paid, and ensure that it gets paid. That is the whole discussion with account abstraction, when, in how many steps this pay gas instruction has to happen. And with EOF, you could just have a section which says how much gas you prepay from the account for the init code, or this abstraction code. So it may bring back account abstraction into consideration. And I guess lastly is really just tooling, which I guess is an added benefit, but it doesn't really make any difference to on-chain, because these are really just off-chain use cases. But compilers and frameworks definitely could benefit from having the separation, or having all these other features we discussed. Because right now, for example, all these frameworks dealing with Solidity code, they have their own different container formats for the code and stuff around it, and they could actually just use this container format with special sections to store artifacts. And I guess lastly is really just any kind of analyzers, including static analyzer tools. They could be simplified. They definitely can work already, because they practically have unlimited resources. They're off-chain, but this would make I guess analysis nicer for them. But I mean, this tooling, because it's off-chain, it's not the main motivation for any of these.
So would something right now you can have your code deployed, and then view it on Etherscan once it's been validated. Something like that would be easier for Etherscan to do with this kind of system versus now.
Yeah, well, the Etherscan validation, I don't think that would change at all. But yeah, I mean, any kind of auditing tools could benefit, because so if you look at formal verification, and the example where formal verification is concerned by the bytecode. So if you look at, for example, the deposit contract, what they had to prove is, what every single code path, what it ends up with. And they also had to prove that nothing really gets into the metadata at the very end of the bytecode. And if you have this separation, they wouldn't need to prove that single property, because that's inherently by design. And I guess you could say that such kind of formal verification would save a bit of time and money if you have this separation.
I have some more questions, but I don't want to. Other people have questions. I want to make sure they get them in, and that you guys get through all that you want to do.
All right. So I have a couple of more questions. One is directly from this slide. It may be a very, very dumb question. Point number 2, you mentioned here, easier application of existing EVM instructions such as self-destruct. We are already having a proposal for reducing refund. Was that needed if we are already having this?
Yeah, I would say these are kind of orthogonal in the sense that, yes, you can more easily deprecate such features, but obviously you can only deprecate it for new bytecode. Old bytecode, you cannot. This won't really affect old bytecode. So this is kind of in that sense not a complete solution. but where this helps, if in the future, let's say you have EOF and you have this restriction that only EOF code can be deployed, legacy code cannot, then deprecating features will be easier because you will have a fixed set of contracts which could be affected. Because right now, even though you want to say deprecate self-destruct, this list of contracts which exist on mainnet, this is unbounded. People can keep deploying such contracts. So at least if you have like EOF and we disallow deploying non-EOF contracts, then we reduce the number of contracts we need to investigate every single time we want to deprecate something or change something.
Makes sense. I have a couple of more questions. I believe those are going to be real quick. So with the expectation of EIP-3540, maybe in the following upgrade, what if for any reason this proposal, EVM object format proposal, is not deployed on the mainnet? Do we see any redundancy with the format proposal 3541 on the main chain?
I wonder if I should answer. But yeah, Andrei, Paweł, you guys should feel free to speak up. I think Paweł mentioned this earlier. So if 3540 is not deployed in the end, the scheme of like using this EF byte can be utilized by other proposals. Or in the worst case, if it turns out that nobody ever going to need anything like that, that restriction of 3541 could be lifted. So it's pretty harmless. It just opens up the door for any progress. And whether it's 3540 or something else, it just make it possible to do such proposals.
Yeah, I mean, I can see on an individual, it has a lot of advantages, but I was curious. Paweł, you were trying to say something?
Yeah. So yeah, that was discussed on the core devs meetings as well. So many of these. So kind of starting from the back. So many of these potential future uses, I think they come up. They kind of are related to the concept of code versioning, and this is not something new. It was discussed and yeah, it has been designed before. But back then we couldn't actually get it done. So the change is we kind of find a way to do that with this prefix, and so the most importantly, it doesn't require to change the Ethereum state tree structure, which was one of the way of getting code versioning. So this code versioning mostly is the reason it's easier to deprecate some stuff in the future versions, because you can always bump the version and differentiate by that. Yeah, EIP-3541, it's kind of enabled to get code versioning, and we propose to do it specifically with this EOF prefix, and as some people mentioned, it's not really, it doesn't actually break anything, and it's if not this EOF, it's good and able to have any other kind of code versioning and some kind of way of deprecation.
That make a lot of sense. Thank you. So one last question. It's about EIP-3540. Currently, the status shows it in draft. Like the way we have discussed it today, it looks like it's more or less like already set in stone. So is it now ready to be moved to review, or do we want to see it for some more time in draft?
I think it would be pretty much ready for review. But one thing we want to change is probably just remove this notion of like the two hard forks and move it outside of the document. So in fact, we're working on like a separate explainer, and I think this call definitely really ties into that as well. But yeah, otherwise, I think it would qualify for the review state.
So yeah, that's all with my questions. Anyone here on the call today, if you have any questions?
I have some more, but I'm going to give space for anybody who wants to raise their hand. A question about versioning. So I noticed one of the rules of validation is that it won't accept any other version. It's like rule 6. Are you envisioning that like every version will be kind of a discrete thing, and then you'll move from one version to the other, or like a compatibility between versions, or is that even just thinking too far ahead to even matter?
So yeah, this is wait. Yeah, this is kind of simple thing. We don't want to. So it's a similar story to what we currently try to do to find a prefix that has not been deployed previously, and all this trickery with the two hard forks, and it's kind of the same situation. So you don't want, when you only have EOF1 specified, you don't want to someone's deploy code that starts with EOF2 prefix and any other version. So like it's reserved for future use. So it's when only EOF1 is specified, you cannot like deploy future versions because simply they're not specified yet, and you could not verify these. So this is only because of that. And if we going to like design EOF2, if any, then we have to decide like how the different versions will interact with each other. So if you could still deploy EOF1 or not, or yeah, it complicates. It gets more complicated when the new version introduced. But this rule was just because of that, to reserve the any other version for future use.
And then the next question is, so the current stuff that's validated is JUMPDEST. Like if you do a jump, you have to land in a jump destination thing. Is that something, and then the new rules are going to also contain that. Is that something that we inherited and then we're just like, okay, we have to deal with it, or is it like a good idea in general and we should do it? Like, why sort of is that on its own? Or like, why did we do it in the first place?
Yeah, yeah, that's a good question actually. So I know why it's done, and I'm not sure if it's still relevant. So it comes from design that we prototyped very early when EF was like pretty close to the final specification, but not like freezed yet. And then we prototype EVM implementation that actually generates machine code. So it translates that to like machine code. It's kind of like JIT compilation for EVM. This project was kind of promising back then. And the problem is that when you can jump anywhere in the code, there's no way to translate that. You would need to kind of mark all of you would need to mark all of the bytes in the code as a valid jump. There was no way to implement it. So that's why we introduced this like special markers when they are like, at least they list all of the potential jump destinations. Yeah, and that's, so it wasn't there at the beginning, so that was added pretty late in the, like, considering the Ethereum 1.0 specification. Yeah, what it was done. So why I'm saying it's not super relevant anymore, because actually, I don't believe anymore that this like JIT compilation is really like very useful, at least these days. So yeah, maybe in the future someone like spend a lot of time on this, but I think the interpreters are good enough that it's not critically needed. But yeah, not having that enables some additional quirks in the EVM. So the other problem is that you have also some like constant values mixed in the bytecode. So like if you want to like add 1 to something, you have this 1 value somewhere, and you could actually jump to this one, and EVM would interpret this one as a add instruction. So it kind of would work, but it might be nightmare for like analysis. So this is avoided currently. I'm not sure like what other people thinks about that. Because like many of the EVMs are kind of pretty simple implementations anyway. And this pretty simple implementation, if done with some like, well, carefully, but not over designed, are pretty much okay. So this could work, but yeah, maybe some other people would have some restrictions to that, like from like security analysis perspective or other things. So I'm sure, like I think it's up to discussion, but I'm sure we want to. I'm rather in the position that, yeah, it's not great, but I would rather like make it more restrictive and encode it efficiently in the bytecode than lifting it entirely. But yeah, that's also the possibility.
When you said late, you mean like post Homestead, or like what is later in the design?
No, it was done before the frontier. So.
So it was like before the launch, but late in the design.
Yeah, I mean late because yeah, this is something we proposed, and we joined kind of like when EVM was kind of specified. So we were implementing this JIT compilation for already existing specification, right? So the specifications was there, like yellow paper was already present, and we are implementing this proof of concept JIT compilation based on the yellow paper. So it was done. So the code, the gas costs were not assigned back then. There was some like, I mean, there was like different costs, but they were like based on nothing specifically, and then it was benchmarked more carefully, let's say, and the code, the gas cost changes also back then. But the only addition I think to that was the JUMPDEST opcode. Yeah, probably the biggest change in the EVM I have seen.
Some fun history.
Yeah, it was many years ago. So it feels pretty ancient now.
Just this is like an observation / question. That so I when I first looked at this EIP-3541, like you have quite the heavy hitter author list as far as Ethereum core development goes. It's kind of cool for people who don't know or just getting into Ethereum development, like between Alex, Martin Swinde, Alexei, and like the Paweł and Solidity team. It's like the who's who of core development. It's kind of cool.
I wonder how to explain that. So I'm not sure if that was kind of like pretty cautious way of doing, but we just like informally discussed this stuff before like specifying it or like even writing anything. So we kind of like, I would say like went, a bit, I don't know, offside by firstly like reaching people that kind of had opinion about that, to make sure like, we kind of agree that this is the good direction. But the most importantly, this breakthrough how to actually deploy that was done during this discussion. So it looked much worse when we started working on it in terms of how to deploy that. But it was nice to have these people like involved very early. But I consider that to be like kind of privilege we were in, that we could organize this group semi-officially.
And it seemed to happen pretty quickly as far as like hearing about the proposal and it being talked about and it going into, that was pretty cool too. And maybe not the whole, like the proposal itself.
Well, like, it wasn't bad in terms of timing. I mean, I did much worse previously in many other things. But I'm sure I'm not really good at remembering when something happened. So it was 1 or 2 months before we even said anything publicly about that. So
one of my questions as well, like in like very small period of time, all clients implemented it, the pull request, and now finally it is on Calaveras, the DevNet. So it's an incredible job by all the proposers as well as the implementers team. Well, thank you, Alex, Paweł, and Andrei for taking out time and talk about these EVM related proposals. Also, many thanks to James for helping out with these questions. So I think EIP-3541, like this is the fastest moving proposal, as I mentioned. Once again, I would like to congratulate for this perfect coordination. I hope the release of this video may help proposal 3540 to get more feedback to move it forward. And now that my understanding is the authors are considering it to put into review, so we can expect a lot more reviews. On this note, for all our YouTube viewers, thank you so much for watching. I hope you like the episode. And if you care about these proposals, please do share with people of similar interest. If you have got any feedback for EIP-3540 or 3541, leave a comment, reach to Ethereum cat herders or the co-authors, or you can also directly add comments in the Fellowship of Ethereum Magician, the discussion link. All details are provided in the description box. Few announcements. Ethereum cat herders are conducting a user and developers survey. It's going to be a feedback for the developers and the client team in terms of tools and documentation. What is the expectation of the new developers joining in? So please take out time to fill up the feedback form. Today there was a release of London blog post. It lists all the proposals which are currently on the 3rd developers testnet. Do give it a read and you will get an overview of what to expect with the upgrade that is expected next month. Next week we are going to talk about another proposal, that is London upgrade EIP-1559 with Tim Byko, PEEPanEIP, and Marka Zoltu. See you all in the next episode. Till then, keep watching, keep sharing your love with the Ethereum cat herders.